Welcome to Trig 8.4. This will be an almost do-over of what we did yesterday with a new word and a new calculator button. So today we are talking about permutations. Permutations are anything where you have something be arranged in order. So yesterday we had that going on, like putting baseball players in position. The order mattered. If you've ever had any baseball, softball experience, you realize if you have one person pitch versus another person pitch, that's a very different product on the field. Certain people are only capable of playing certain positions. Or we did some things yesterday with words. I think you're aware that if you mix the order of the letters around, you have a different word. That matters. We couldn't take Nina's name and scramble it up like that with the same letters and act like that's the same word anymore. That's obviously not a thing. The words order matters. Every story today that you'll encounter on page 243, the order will matter in some way. In a coming day, I think it's 8.5, the order will not matter for things sometimes. And then we'll have to think a little bit about trying to tell those circumstances apart. But for today, the order will matter every time. So they're back to some similar stories like yesterday that I have on your notes paper and I have on the board as well. If you don't want to cheat and look ahead and see what the answers are, you might have to put that notes paper away. But I'm doing a repeat of that. And then I added in a few other ones because usually spur of the moment I add in some problems just through interaction with people. But I don't have that ability, so I'll just do the best I can. So the first thing, we'll go back to those words again. And just in case you were misunderstanding yesterday, we're not worried about words that we would find in the dictionary and confirming that they're words. We're thinking in terms of words like you get down and play with your youngest sibling or niece or nephew or whoever, and you have blocks and you just make words. And they're just like, oh, what did we spell? And you're like, we spelled the word, but look at all the blocks and a block up. And you just act like that's a word for the duration of that game. So if we have 3 letters to choose from, we have 3 blocks with our young child friend, like A, B, and C. If I wanted to make 3-letter words in a long way, I could like list them out. A, B, C could be a word. A, C, B could be a word. We could do a couple words that start with B, back, and booka. I could do some words that start with C's, kibba, and cab. Only one of those words is a legitimate word, cab, but we would count there to be 6 air quote words there. I don't think you'd be real excited about listing out all the combinations very often for these problems. Like in a minute, we're going to step up and do 10 letters to choose from and make 10-letter words. That is going to be a very large number. Okay, so you would not want to sit here and list out every way you could scramble up the letters A through whatever the 10th letter might be to make all these ridiculous words. So we need a way to do this, and we did that yesterday. If we're going to make a 3-letter word, we need to pick a first letter and multiply. Pick a second letter and, so multiply. Pick a third letter. To build a 3-letter word is an and problem. I didn't use the word and in the sentence today, but that's an and problem. To build a 3-letter word is to pick a letter, and pick another letter, and pick another letter. And that's one of those decreasing problems where you're using the numbers as you go. So if I wanted to do a 10-letter question and make 10-letter words, I would have 10 choices for the first, and another letter is 9, and 8, and 7, all the way down till I use the 1. And we learned yesterday we had a new button for that. You might not want to punch in 10, 9, 8 all the way down. You might rather just do 10 factorial, which is 3,628,800. If I want to do a 4-letter word with my 10 letters, I would need to multiply 4 numbers together. My first letter is 10 choices, then 9, then 8, then 7, and we could just punch that in. I have 4 numbers here for my 4 letters, starting with 10 to choose from and going 10, 9, 8, 7. So that's going to go 5040. If I were going to use the whole alphabet, I would have started from 26. 26, 25, 24, 23. If I wanted to use the whole alphabet and you make a 26-letter word out of the alphabet, I would go back to the factorial idea. You use the factorial button anytime you're using up all your choices. So 3 letters, make 3-letter words, use up all the choices, that was a factorial button. 10 letters, use all 10, that's a factorial button. 10 letters, use only 4 of them, that is not a factorial button. We'll just multiply that out for now. If we're arranging books on a shelf, the order there matters. If you don't believe that it matters what order you put the books on a shelf, go to the library and try it out. The librarian might bite your face right off if you just start randomly throwing books on the shelf. The order matters when we're putting books on a shelf, so that's a permutation is the word of the day. Permutation is any arrangement where the order matters. So if I have 7 books to choose from, and I'm going to put 3 of them on the shelf, I would do book 1 and book 2 and book 3. If I'm doing 3 books, I need to multiply 3 numbers together, starting with 7, and we decrease as we go. Because you're not going to shelf the book and then shelf it again. You can't. It's already been shelved. We need to decrease those choices as we go. And that would be a 2 10. Let's say we have a roster of 12 basketball players and you want to position 5 of them. The order matters. Anybody with any sports experience knows it does matter what lineup you put out there on the floor to pick your starting 5. It does matter which one you make the point guard. It does matter where they are. The order matters with those choices. So if I'm going to do 5 players, I'm going to have to multiply 5 numbers together, starting with 12. When I pick my first person, I have 12 on the bench to look at and choose. Once I pick that one, I have 11, then I have 10, then I have 9, then I have 8. I multiply that all up. It's not a factorial kind of question because I'm not using everybody in that choice. So you multiply that up, and I'm peeking on my paper to cheat because I don't want to do that one in my head. It's 95,040. That style of question is how the page 243 is going to go up through 10. Up through 10, they just want a count of how many ways can this be chosen. They might use the word permutation sometimes. That's just a count of how many ways this can be chosen. Starting on 11, they start to mix things up. Okay, starting on 11 and going until about 18, they're like the question I'm about to do, where sometimes they'll ask you how many permutations are there. That's what we were doing. But they'll also start to ask you about some probabilities, which will bring some fractions into play. Anything that asks you about percentage probabilities, just feel free to skip that. I'm good with just you staying true fractions, doing some reducing. I don't really care about you transferring those into percentages. So if you want to skip those, feel free. But any question that asks you for how many permutations, do what we just did. But if they ask you a probability, make a fraction. Over here, I put the little P symbol to stand for probabilities. So these 4 are going to be fraction-y answers. But my first question is not a fraction answer. So here we go. We're going to do a 7-letter so-called word. Not worried about a dictionary word, but just a random assortment of 7 letters. Using the letters in the word sequoia. I think they liked in the book using the word sequoia because there's lots of vowels in it. I think I stole this problem from the book, potentially. Looks like I did. Yeah, I stole that just right off of page 242, 243. So if I want the possible permutations using all those letters in sequoia, you could go 7 times 6 times 5 times 4 times 3 times 2 times 1. Or you could go 7 factorial if you wish. And that is the 5040 from yesterday. If they ask you to do a certain kind of probability, then we're going to need to make ourselves some fractions. And for this story, the bottom of every fraction is going to be 7 factorial or 5040, whatever's more convenient to you. I'm not sure what the stories are yet, so I just did 7 factorial on all of those for now, but 5040 can stand in that place in a minute as well. And then they'll tell you a story. Suppose you have a Q first. I didn't write the word and, but the comma is like where the word and could go. We're going to go Q first and a vowel last. So if my Q is first, I have one choice because there's one Q in that word. If I want to do a vowel last, 1, 2, 3, 4, 5 choices because there's 5 vowels. And there's sort of a hidden thing here implied because we're building a 7-letter word. I did a Q here, I did a vowel there, which means there's these 5 other spots that you can just do whatever you want. The 5 do whatever you want spots could be 5 factorial because you have choices 5, 4, 3, 2, 1 choices to count from. To simplify this, canceling factorials is interesting. If you were here, I would eventually tease this out of you. But 5 factorial can cancel 7 factorial. If you want to try to figure out what's left, pause the video and take a minute. If you're back from pausing, this would leave a 7 and a 6. If you want to figure out why it's a 7 and a 6 on your own, pause the video again and figure it out. But if you're unpausing, I'm going to tell you the answer, which is this means 5, 4, 3, 2, 1. This means 7, 6, 5, 4, 3, 2, 1. They both incorporate 5, 4, 3, 2, 1s, but this has an extra 7 and an extra 6. So if 7 factorial, 7, 6, 5, 4, 3, 2, 1 cancels the 5, 4, 3, 2, 1, we're going to get 5 and 42. I think it's easier to reduce by canceling the factorials with that trick than it is putting 50, 40 on the bottom, punching in the top, and having something with like 1,000 over 5,000 and trying to reduce it. If I wanted to change this question slightly to have a Q first and a consonant last, that would change only this number because we still have one choice for the Q. You still have 5 do whatever you want positions, but to pick a consonant in the last slot, some of you might think 2 because there are 2 consonants, but it's not 2. It's 1 because you used up the Q. The Q had to go in a certain position and it got used, so you're only left with one other position. Me saying a consonant last is the same thing as me at that point saying an S has to go last, and there's only one choice because S is your only other consonant. That would be 1 over 42. If I want to do a vowel first, that would give me 5 choices because there are 5 vowels in that word. And, so I'll multiply. Consonant last would be 2 choices, Q and S. And then I didn't say it in the parentheses in the telling of the story, but you still have 5 do whatever you want spaces. 5, 4, 3, 2, 1 can cancel 7, 6, 5, 4, 3, 2, 1 to leave the same 7 and 6 as before. 42 on the bottom. Disagree with myself already. I would do another quick cancel. 2 can cancel 6 to leave 3. Top has a 5, bottom has a 21. So let's do a vowel in the first 2 spaces. So first space would be a 5 choice. Second vowel I'd have 4 choices because I used 1. And then the rest of the word, just do whatever you want with 5 factorial for the other 5 slots because there's 7 just freedom slots for 5 of them. This can cancel this to go 7 and 6 again. 4 and 6 I can get a little mini cancel because 2 goes into both of those. And I'd get a 21 bottom and a 10 top. Let me double back to this one and let me do vowels for the first 3, just to get a little bit of a different thing than what we've been doing. If I want to go vowels in the first 3 slots, I'd go 5 for the first vowel because there's 5 vowels in the word. I'd go 4 for the next one because I'm short 1. I do 3 for the third one because I'm decreasing every time I pick a vowel. The rest of my spaces now is a factorial, always to fill in the freedom up for grab spaces. But this time it's 4 factorial because I filled 3 positions out of 7 letters that left me 4 to do whatever. If I had picked a 4 here, it would leave me 3 positions of freedom. If I did all 5 vowels, it would leave me 2 positions of freedom. This is just the leftovers. 7 factorial on the bottom. The 4 factorial can get rid of 4, 3, 2, 1. If we get rid of the 4, 3, 2, 1 part of this, it would leave 7, 6, and 5. The 7 factorial goes from 7 all the way down, but the 4 got rid of everything that was 4 and lower. Further cancels, 5s could go. Further cancels, 3 into 6 goes twice. Sneaky recancel, 2 goes into 4 twice. All told, 2 on the top and 7 on the bottom. The last one is sort of a weird one. If I asked you for this group, specifically A, Q, E, S, I, O, I, U, I want that ordering of that letters. Well, if you want to do that a long way, I gave you 1 choice for the first letter, 1 for the second letter, 1 for the third letter, 1 for the 4th, 5th, 6th, and 7th letters. If I've demanded this combo, each slot, I only gave you 1 choice. And 1 times 1 times 1 times 1 times 1, it's kind of a silly way to do that out. It would be easier to just realize, if I request this 1 item, I only gave you that 1 choice, no wiggle room. And the bottom would be 50-40, because we've known about 50-40 from the very top. When you go to do the homework, 244, 11 to 18 are like these. When you get to 19, 20, you're going to have to think a little bit. Those are going to be more challenging questions. Those might be Zoom questions for another day, but at least try them so you have some thought of them, so we have a start on our conversation. 21 is like the previous day's lesson. I never the first day tell anybody how to do 21. Just read 21. They explain 21. See if you can figure out 21 just from reading. 22 is nothing to do with 21, but a similarly styled question. I never explain 22. See if you can read 22, understand 22, do 22. They're loosely connected to this lesson, but I never do examples for those. I just see if people can figure out from what the book hints they're dropping you if they could do 21, 22. But email me if you have questions. If the factorial canceling completely freaked you out, let me do 1 more of those for people that want to stick around. So, director, pick any number 10 or less.
8.
Pick any number that's more than 8.
9.
So if I were going to cancel these, this would mean 8, 7, 6, 5, 4, 3, 2, 1. This would mean 9, 8, 7, 6, 5, 4, 3, 2, 1. All of these would be able to cancel except the higher number, 9, would be left because you ditched everything from 8 down. That would be 1/9. If that helps you, it helps you. If not, I'll try that again another time. Just email me if you have questions. I'll try to explain. Good luck.